Unit 6, Day 9, Lesson 4B, Review Combining Like Terms. So just like Lesson Day 8, Day 9 is a review of a 7th grade standard, 7EE1. And again, this lesson is going to be super critical for students' understanding once we start working with polynomials and we're adding and subtracting terms in polynomials. So we want students to have that solid understanding right now. And so just like Day 8, it will be important for students to have an understanding of these key vocabulary terms. Students aren't going to really factor in this lesson, but they will be expanding and they will be simplifying and finding equivalent expressions. And so for this one as well, I'm going to talk through the explore portion of the lesson, and I'm going to model how you can use the resource of algebra tiles to teach combining like terms, or to give students who might need additional support with combining like terms a resource. You can use algebra tiles for a number of things. You can actually use algebra tiles for factoring and distributing as well, and we can get into that more in a future video. But for today, I'm going to show you how to use them for combining like terms. And so there's algebra tiles all over the internet, but this is a good resource, and I'll share this in the video. This will be linked in the to the video. But let's just look at this simple one: 9x plus 5y plus 3x plus 7y. I'll type it onto the screen. And because this is a review lesson, many students won't need to use this as a resource, but this is really useful for your students with special needs who might need, or students who just maybe didn't learn this last year, who might need like a very concrete representation of what's happening. And so if we're just going to represent this with algebra tiles, we're just going to have 9x's. 1, 2. This is a pretty simple one. And this, the nice thing about this is it shows students exactly in a very concrete pictorial way what is 9x. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 5y's. And again, simple, basic problem. And then we're adding 3x and 7y to it. So we could simply just put the 3x's over here, or we can separate it maybe, just so students can see the different expressions. Oops. Oh, that one's on there. Let's put this over here. And then 7y. And for this one, the key point, right, is like we usually tell students, okay, now look at the terms. Where do you see, another x? Let's circle the x's. And then let's box the y terms and let's combine those. But why are we only combining the x's and the y's? Well, here we can actually physically see, oh, this is going to be 12 x's, and this is going to be 12 y's. And so our simplified expression is 12x plus 12y. So it takes this very abstract representation and it gives it to students in a concrete way. And so now let's look at one that's a bit more trickier. Just going to refresh. Oops. Refresh the page. And so let's do this one. 9x plus 5y minus 3x plus 7y. And this is a huge misconception. This is probably one of the biggest misconceptions that we see in 7th grade. And we also see it continue in 8th grade. And what I've noticed, oops, I just want to see what's down there. What I've noticed is it really helps children to visually see what's happening when we distribute the negative. Oops, or students, I should say students, not children. Okay. So this is where kids are just going to subtract 3x and then they're just going to add 7y. And we want to reinforce this idea of distributing the negative. So first, let's just represent that first part of the expression, 9x plus 5y. So it's the same as before. 4x, 5x, 6, 7, 8, 9, and 5y's. 1, 2, 3, 4. So what I like to emphasize to students here is that one of the key ideas I like for students to just understand in general is that a subtraction sign can mean 3 different things. Or it means 3 different things all at the same time. Okay? It means negative, it means subtract, and it means the opposite of. And all of those things are synonymous. So sometimes students will say, oh, is this a negative sign or is this a subtraction sign? Those mean the same thing. Having a negative number, right? We know adding a negative is the same as just subtracting that number. So these are basically synonymous. And so when you see an equation like this, what we're thinking about is really 9x plus 5y plus, oops, that was a 0. The opposite of 3x plus 7y. And so once you kind of add, well, subtracting is the same as adding the opposite, and we get students to that point of understanding. Now we can rewrite this like in this equivalent way, and we can say to ourselves, oh, we just have to add the opposite of everything inside these parentheses. So instead of 3x, I'm adding the opposite. Oops. Of 3x. And these are really nice tiles because you could just click them like this. And instead of 7y, I'm adding the opposite of 7y. And if you're going to use algebra tiles, 1, 2, 3, 4, 5. For this lesson, one key idea that students are going to need to really understand is this idea of a 0 pair. An x and a negative x are a 0 pair. They cancel each other out. 5 and negative 5 are a 0 pair. They cancel each other out. And so when we have algebra tiles and we're combining like terms, we're going to look for 0 pairs so that we can cancel out values. And when we say cancel out, it's really useful when we say cancel out to actually say make 0 when we're adding, or we could say when we're multiplying, it's making a 1, right? And so cancel out becomes so abstract. And what are we doing when we cancel out? Well, we're making these numbers into zeros. We're making these into zeros. So that's a 0 pair. They cancel out. They cancel out. And they cancel out. I'm going to move this over just to show that distinction. And now we have a couple 0 pairs here. And so again, it's very tangible, very concrete, very visual. And this could be a resource for everyone, even for kids who do well. It's some kids may have memorized the rules and the steps to solve this, but do they conceptually understand what it means to combine like terms and make these 0 pairs? And this is great for that. And so now what's left? 1, 2, 3, 4, 5, 6x and negative 2y. And we could talk about, well, we can represent it that way. What's another way to represent this? Plus the opposite of 2y. 6x plus the opposite of 2y. We can even do this way. What about another representation, right? So really diving into this, well, we could write it as negative 2y minus negative 6x. Interesting. And again, you don't need to get into every single way to represent this expression. There's an infinite amount of ways. You could even pull from yesterday and say, oh, we can use the distributive property and represent it like this. Interesting. Where do you see that? 2 groups of 3x and 2 groups of negative y. Oops. Oh, right here. 2 groups of 3x. Oops. 3x and 3x. 2 groups of negative y. So again, very visual, very concrete. Give students a way to visualize What is happening when they combine like terms? What is happening when they distribute the negative? What does that mean? And the more you give them this resource, especially for students who are struggling with distributing the negative or knowing what to combine, the more they're going to internalize what it means to combine like terms, and the less they're going to need this resource.